So I wrote here momentum, that's the amount of motion an object has. The more motion an object possesses, the more momentum it has. Momentum is really going to be used to look at collisions and tackles. Those are the two best, quote, real-world applications of momentum. Car crashes, it's the physics of car crashes, and you can think of a football as a football tackle as a watered-down car crash, or a body check in hockey as a watered-down car crash. So what I've tried to do here is give you four stick figure diagrams. The size of the circle tells you whether it's a big mass or a small mass. The length of the arrow tells you whether it's going fast or slow. Just to put it in context, let's make this small little thing here. Let's make it a bullet. If I tossed a bullet at you underhand, is your life flashing before your eyes? Are you too worried, or is it kind of meh? I'm willing to bet most of you could even say, you know, if I had to, I could even let it bounce off my face and it would hurt a little bit, whatever. So this is going to be a small amount of momentum, of motion. Now, what about if I fire that bullet from a gun? Well, now you're not so interested in trying to catch it. Has its mass changed? But its velocity has, the same as when I said I could spike that ping pong ball at Matt overhand. Its velocity would have changed. He probably would have flinched. Okay? So here, this is going to be a larger momentum. One way to up an object's momentum is to increase its speed. What if I replaced the bullet with a bowling ball? But I didn't fire the bowling ball from a gun. Well, that's still got a fair bit of momentum. You still would not want to let that hit you in the face, I don't think. So this is also going to be a larger momentum. But the worst damage, Haley, the most damage, are when you have an object with big mass and a fair bit of speed. A bowling ball traveling at the speed of a bullet. And we have a name for that. We call it a cannon. That's really what a cannon is. Okay, this would have very large momentum. Another example of something with a big mass and a fair bit of speed is you've all watched movies enough, I'm willing to bet, that at least once you've seen in the movies a locomotive hit a car. And that locomotive has enough speed and enough mass that when it hits the car, it barely twitches. It has so much momentum, it can afford to give some of its momentum to the car and keep going on its merry way. Quite, thank you very much. Yeah? Train. Train. Learn a new word today? Good, you're becoming perspicacious. It says, explain your answer. Rather than explain by writing out a paragraph, I'm going to hope the game of catch that Matt and I played was clear enough. What would be a good variable, a good letter to use for momentum? Oh, why can't we use M?
Mass.
So what letter do we use for momentum?
Oh.
Kedra, did you look at the formula sheet cleverly ahead of time? It's interesting. 3 of my blocks, people figured that trick out. 1 of my blocks, everyone just sat there drooling. Go figure. What letter do we use? We use a lowercase p. Why p? Because it's mass times velocity. Another word for times is product. Momentum is the motion product. Also because m is taken. So we can write this. P equals mv. Although that isn't quite right either. You're going to notice in this unit, I'm going to start paying way more attention to direction. Again, momentum is the vector. So if you could do me a favor and put the vector symbol, that half arrow above the letter P and above the V, not above the M because mass is a scalar, but above the velocity. Momentum gets its direction from whichever way the velocity is. If you're traveling north, your momentum is north. What would the units for momentum be? Momentum is what times what? Momentum is what times what, everyone? Momentum is what times what?
Mass times velocity.
Momentum is what times what?
Mass times velocity.
I'm going to keep going until everyone participates. Momentum is what times what? Okay, we got colon. You don't need to memorize that one. Please notice where it is on your formula sheet. But just like you didn't technically need to memorize F equals ma, I'll encourage you, it's worth during this unit to memorize momentum equals mass times velocity because you get sick of looking it up. Also, notice how many variables are there in this equation? 3. So technically, how many equations in one does it actually contain? There's a way to rewrite it for velocity. There's a way to rewrite it for mass. We'll talk about that a bit later. Momentum is what times what? It's mass. What are the units for mass? What are the units for velocity? What are the units for momentum? Kilogram meters per second. It's kind of hidden in the equation. That's a bit of a long, almost a tongue twister to say all the time. 5 kilogram meters per second. There was another one that was kind of long. F equals what? Force was equal to kilograms meters per second squared. That's MA. But we never said that. We gave this a name. We decided in physics that we were going to call a kilogram meter per second squared a what? A Newton. We named it after Sir Isaac Newton. There is a movement afoot. It hasn't come through yet, but it might happen in your lifetime to rename a kilogram meter per second an Einstein, because he doesn't have a unit named after him, and he should have one that has something to do with speed or velocity, because that would make sense. There's actually an international committee that decides these things, and so it's up in the air right now. It may happen. For now, we're going to say that momentum is kilogram meters per second, mass times velocity. Although there's another way to say momentum. A Newton times a second, a Newton second, also turns out to be a unit of momentum. Really? Well, yeah, because a Newton, I just finished saying, is a kilogram meter per second squared. So if you multiply that by a second to get a Newton second, then can you see there's one S on the top, and I would cancel out one of the S's on the bottom, and lo and behold, left behind, you have a kilogram meter per second. That also hints that there's another formula or method for calculating momentum. Which units are correct? I won't be fussy, Chelsea. I won't take marks off if you use one or the other. I will flip-flop. If I have found the momentum by multiplying a mass times a velocity, I'll probably give my answer in kilogram meters per second, because that's the units that were in my brain at that time. If I have found the momentum using a force and a time, I'll probably give my answer as Newton seconds, because that happens to be the units that are in my brain at that time. But I won't, if you have found momentum using a force and a time, and you say kilogram meters per second, I won't take marks off. So I've introduced a new concept to you, momentum. Whenever I introduce a new concept, I like to try and give you an idea of what's really big and what's really small. Ballpark figures, so that if you make a really bad calculator mistake, you can look at your answer and that doesn't seem right. So let's do that. We're going to estimate the momentum for 3 things. We're going to estimate the momentum of a top pitcher's fastball, a major league pitcher's fastball. We're going to estimate the momentum of a person and bicycle on a relaxed ride. We're going to estimate the momentum of a car driving on a city street. But we're going to estimate them in kind of a grisly way. We're going to estimate in terms of how much it would hurt if it hit you, if you absorbed that momentum. I'm going to argue that even for a major league pitcher, as long as the baseball doesn't hit you on the side of the head, if it hits you in the torso, if you get hit by a baseball, I think that's ouch. You'll say some swear words, you'll drop an F-bomb, you'll rub a bruise, but we're probably not calling 911. I watched enough baseball. Batters get hit fairly often. Not in the head, they wear a helmet, so there's some variance in what I'm saying. It's certainly possible that the amount of momentum contained in a baseball could also be fatal, but broadly, Chelsea. What if you were walking on the sidewalk and somebody on a bike riding slowly hit you? I don't think that would be terminal, but I think that might be injury. And by that I mean you might be having to visit a doctor or a hospital. You might break a bone. Maybe not. It's possible you could walk it off too, but I'm suspecting this is enough to kind of, well, you know what? Here you're helping yourself away. Here someone else is helping you away, probably. What if you get hit by a car driving on a city street? Probably. And again, it's possible to get hit by a car and survive. Also, a lot of this depends on how fast you absorb that momentum. Do you absorb it instantly, or can you spread it out? You may have noticed when Matt caught the big lead weight, he cushioned it as he caught it. You tried to spread out the time to reduce the amount of force involved. Or if you've ever done an egg toss or a water balloon toss, you learn very quickly to try and cushion the object as it comes in. If I can increase time, I can reduce force. So there's a lot of variance in this, but let's try and throw some numbers in here. What's the mass of a fastball? I don't know. I'm going to do some quick guessing. I'm going to kind of use a Fermi method of guessing. Is a fastball 1 kilogram, or is that too big? Too big. In fact, I think a half a kilogram is too big. If you want me to just make a rough guess, I think a baseball, a hard ball, a fastball, I think it weighs about 1/4 of a kilogram. I actually did look it up. If you look at the next example, I think I looked it up in the next example, didn't I? So my guess of 1/4 of a kilogram is pretty close. It's a tiny bit high, but it's close. Ballpark. What's the velocity of a top major league pitcher? There's a bit of a problem because I watch the major leagues on American TV, and so my units are going to be in miles per hour, but we'll start there. The best pitchers, what's a nice round number that the very, very best pitchers can hit in miles per hour? A nice round number that the very best pitchers can. 100. If you're not cracking 90, you're not that good. Not in the major leagues. Okay. I think it's Aroldis Chapman can hit 105, 106. I think he's the freak out of the 25 fastest pitches ever. I think he has 17 of them or something ridiculous like that. But let's use 100. Now, 100 miles per hour. Do we do physics with miles per hour? I know a bit of a trick. I know that if I want to go from miles per hour to meters per second, it's divide by 2. 100 divided by 2 is, and a little bit smaller. You know what? I'm going to go 40 meters per second because I have a feeling my mass is a bit big, so I'm going to make this a bit small. Also because I don't want to have to use a calculator. 0.25 times 40, multiplying by 0.25, what's that the same as dividing by? 4. This is 40 divided by 4, which all of you can do in your head. If you absorbed 10 kilogram meters per second all at once, ouch! But we're probably not calling 911. Again, depending on where it hits you. In your eye, okay, we're probably calling 911. But on your torso, pretty good. What about the bike and rider? Let's estimate the mass of the bike and rider. And again, I'm going to kind of go with a Fermi estimate. 1 kilogram for a bike and rider, or is that too small? 10 kilograms? 100 kilograms or 1,000 kilograms? I'm thinking 100. Now, 100. I also know that 1 kilogram is 2.2 pounds-ish. So 100 kilograms is about 220 pounds. That's a little heavy for a bike and rider, but not much. You know what? I'll just make sure that I estimate my speed a little on the slow side. So 100 kilograms. Now the speed is going to be, yep. This is bike and rider. Yeah. Bike and rider. I still think I'm a bit high, but we're trying to get ballpark figures here anyways. The speed, this one I don't have a good context for. Instead, I'm going to ask the people kind of sitting in this middle row here to help me out. Haley and I are going to be our distance measure. How far apart, roughly in meters, are Haley and I? 1 meter?
10 meters.
By the way, my next guess is going to be 10. I think 10's too big. I think 1's too small. How far apart do you think Haley and I are?
7.
I'm thinking 4 or 5. And I also have the advantage, I've held many a meter stick, and I'm literally kind of rolling it out in my mind. I'm 4 or 5-ish. So here's my question. If I'm riding relaxed, which means I'm not standing up on the pedals going hard, if I'm riding relaxed, can I cover the distance between the two of us in 1 second? Or is that a little far? In other words, if I'm riding relaxed, I'm going to estimate that if I was riding relaxed and I ride to Haley in 1 second, that's about 4 meters per second. Is that too fast, too slow, or just right? You know what? I'm going to make it a bit smaller because I overdid the weight, the mass. So I'm going to say if I'm really relaxing, I don't know. And if you said 3 meters per second or 4 or 5, I'd take all of that. But point being, I can also multiply this in my head. 100 times 2. You know, if I want to generalize, if you're absorbing momentum in the tens, like 10 or 20 or 30 or 40 kilogram meters per second, you can probably do that with your torso. Owie, 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 but I'm okay. If you're absorbing momentum in the 100s, 200, 400, 700, you're probably going to be doing a trip to the doctors. You'll probably break a bone. But you're probably going to still be, in the long run, okay. Car. What's a good mass for a car? Yeah, 10,000 kilograms. Those are moving bands. Those are too big. I'm going to go 1,000 kilograms, give or take. Now, it says the momentum of a car driving on a city street. This one I can be pretty specific because I have my driver's license. In fact, I'm going to hope that most of you know this because you're getting your learner's or your driver's licenses soon. What's the speed limit in kilometers per hour on a city street? 50. We don't do physics with kilometers per hour. How do we convert kilometers per hour to meters per second? Now you will need to use a calculator. Although if I was really clever, instead of 50, I'd use 48 because I think that would work out evenly. But 50 kilometers per hour divided by 3.6, what do you get?
13.88888.
What's a nice round, easy number to do math with close to that?
14.
I'm actually going to go 15 because do people actually do the speed limit? They always do a bit more. And I'm just trying to pick nice round numbers. So 15,000 kilogram. You know what? If you're absorbing several thousand kilogram meters per second, probably not good. Having said that, every one of you has absorbed 15,000 kilogram meters per second of momentum so many times you can't even remember how many times. You absorbed it every time that you went from your city road when you were traveling at 50 kilometers per hour and pulled into your driveway and came to a full stop. That momentum had to go somewhere and your body absorbed it, but it was spread out over so much time, you hardly even feel it. And so that's why I'm saying there's a lot of variance in here. A lot of this depends, Chelsea, on how fast are you absorbing the momentum. It's the difference between cushioning that lead weight as you caught it and letting it just hit you on the chin without any cushion. Same amount of momentum, one's going to hurt way more. Yeah. Yeah, it was a story later. Thank you. Sorry, Ben. Okay. Now, momentum is a vector. Part A. What's part A want me to find, Logan? For number example 2. I really should have said find the magnitude of the momentum because I forgot to include a direction in here. Or I should have said the baseball is traveling at 35. You know what? Let's do this. At 35 meters per second, let's add the word east there. Logan, momentum is what times what? So let's write P equals M vector V. What's the mass of this baseball, Logan? 0.14, and it's kilograms. I did a quick check. If it was grams, I would have done a conversion. What's the velocity of this baseball? That's about 100 kilometers per hour, about 60 miles an hour. This is not a major league pitcher. Oh, I think I can do this in my head. Double check me. Is it 4.9? Inside there's 2 7s, a 2, and a 5. So it's going to be 49 times 10. It's going to be some multiple of 490. Now move that at 4.9. Yeah? Units, Logan? Yep. Direction? East. Question. Let's suppose I wanted to throw a bowling ball so that it had the same momentum as this baseball. How fast would I need to throw the bowling ball? Find the velocity at which a bowling ball has the same momentum. Kyle, what's this B asking me to find? Can you take this equation and rewrite it to get the velocity by itself, please? Sorry, I didn't hear you. Which one of those is correct? What do you want to get by itself? So it stays where it is. What's going to drop down like a domino? Right? Now, I'm kind of glad Kyle made that sloppy mistake because, first of all, based on what we saw, Ben, based on what we saw playing catch with Matt, will I be throwing the bowling ball slower than the baseball or faster than the baseball if I want it to have the same momentum as the baseball? Slower. If I had used Kyle's initial guess of M over P, I would have gotten a velocity faster than the baseball, and I hope that would catch your eye and you would just say, no, I played catch. That's not how it works. So it's going to be 4.9 divided by this. You'll absolutely need to use your calculator for. Although it's going to be something in the 0.6 range, I can tell you that. But not much more than that. No, I think it's going to be something in the 0.6 something range. Not in the 0.7 something range. To two sig figs, please. What'd you get, Ryan? 0.675, so 0.68? Is it 0.68 or 0.67 if you go to 2 sig figs? 0.67? Kilogram, meters. No. What did we just find, Logan? No, Kyle, sorry. What did we just find? Units for velocity are? Direction? I could also give you a momentum and the velocity and say find a mass. So now velocity, we have several ways to find it. Vf equals Vi plus At, Vf squared equals Vi squared plus 2Ad. And again, look at what they gave you, and that's how you go hunting. I like example 3, I like example 3, I like example 3. Example 3 is a nice question. Direction. Momentum is a vector, so I should include a direction, technically. Or I should have said find the magnitude of the momentum, no direction. It was easier just to add the word east. Ben, we added the word east right there, right? We added that, though. I have to give you the direction to do that. It's going to become much more important when we start looking at collisions and car crashes, because it makes a big difference whether it's a head-on collision or a rear-end collision, a huge difference. It makes a big difference whether a bigger car goes through the other car or bounces off the other car. There's all these variables that we'll have to look at. Oscar, what's example 3 wanted me to find? Oh, this is easy, because momentum is what times what? Momentum is what times what? Mass times... It's on your green sheet right in front of you, right? Okay, and they gave me the mass, right? And they gave me the velocity, right? Oh, I like this question. You know what? Since I'm not quite sure what to do, I'm going to go full, careful, meticulous DFIC approach. I'm actually going to go P equals question mark. I'm going to think to myself, I'm probably using mass times velocity, so I'm going to write M equal, what was the mass, Oscar? Did they give me the velocity? By the way, I should put a vector on the P and a vector on the V to remind myself to pay attention to direction here. So my method when I was finding something else is I often just put a blank there to say that's the blank that I need to fill in. What else do I know? Sorry? Oh, so what can I write, Kedra? D equals, that can't be right. And it's not right. Are we ending up below from where we started? And we're back in vector land. Now, again, we got pretty casual in forces because we often had objects moving up and down in the same question. It was easier just to say, let positive be whatever makes the math nicer. Here we're back in vector land, so negative 75. What else do I know? Yeah. Yep. What else do I know? What's VI? How do you know? Dropped. And Kedra, as soon as you said VI equals 0, I went back to my V and I put an F there to say, actually, I'm finding VF, just to make my life easy so I don't have to do as much mental gymnastics. Okay. So I'm going to draw a line down the middle. On the right-hand side here, I'm going to find VF, and then I'll walk it over and find the momentum. I'm looking for an equation that has a VF, a D, an A, and a VI in it. There is one. Hey, are we after spring break? Is spring break finished? We're in the home stretch. This is nice review from the beginning of the year, and I'll try and do that as much as I can, build it into the lessons so that when we get to the end of the year, we will do some final exam review, but it's not going to be, oh my goodness, cold turkey, I haven't seen any of this for so long. I'll try and build it in as we go. Which equation? Keep going. Oh, this is great. I've got the VF by itself already. Or do I? Oh, I have to square root. Okay. And by the way, if I'd been in mid-season form, to be honest, Ben, I could have done this because VI is 0, but I'm fine with us forgetting that shortcut because it's been a while, and I'd rather be more meticulous and not take any shortcuts because I'm a bit out of my comfort zone. I've done this for so long. But if you did cross out the VI squared, I would smile. Yeah, good call. So I'm going to get VF equals the square root of 2 times negative 9.8 times negative 75. Oscar, the nice thing here is if you had missed that negative 75, which you did, you would go 2 times negative 9.8 times positive 75, and when you tried to square root that, your calculator would have said to you, dude, get real, right? Or some error. I like the fact that mine says non-real answer, and so I make that joke, but you would get an error. As soon as you get one of those errors, first thing you want to go check is your signs. Okay? So it ends up being the square root of positive 1,470, I think. And when I do that, I get a V final of 38.34, which is wrong. It must be wrong. Why must that be wrong? What's the square root of 9? Or negative 3. Now, your calculator always assumes you want the positive square root. We have to imagine which way are we traveling when we hit the ground. Which root do we want in physics this time? We know we want the negative root, and there's no way to get your calculator to give you that one. You'll always just have to catch that and say, it's not right. This is good review. Now we're ready to go. Walk this over to here. Momentum is mass times velocity. Oscar, what was the mass? Velocity. I'm going to write negative 38.34, but Oscar, what button am I going to use on my calculator instead? Help them out, folks. What button? My answer. Although I got to be honest, I'm going to go negative answer button because I haven't put the negative in yet. So I'm going to go 12 times negative sign, answer button. And what's that negative telling me? What direction is the momentum when I hit the ground? Down. So you could either say the answer is positive 460 kilogram meters per second down, or you could just write negative 460 kilogram meters per second. Just don't say negative and down in the same question, because to me negative down is technically up. Momentum is negative 460 kilogram meters per second. Matt, momentum is how much motion an object possesses. Depends on two things, its mass and its velocity. You got more mass, you got more velocity, you got more oomph. In a collision, you got more momentum. What's your homework? Every question. I haven't covered every single type of question. I'm pretty sure there's one in the homework that asks you to find the mass. I'm going to count on that if you know that momentum equals mass times velocity P equals mv, that you can rewrite that to get the m by itself. Hopefully you're starting to see why I did so much formula manipulation at the beginning of the year. It cuts down on my explanations at the end of the year. Okay, you got all class to work on this. If you have any questions about missing assignments, you can ask me them. And one of you wanted to ask me about a test score, you can certainly hit me up in about 30 seconds as well.